Hello. So in this section, we are continuing our work with simultaneous equations. So last time we looked at linear simultaneous equations. So these are simultaneous equations, so multiple equations, where, as an example like this, x y equals 7. We have two equations with two unknowns, and they're linear because obviously the degree is 1, so the linear terms, right? So what we're going to look at in this section is actually quadratic. So we're going to kick it up a gear. So we're going to look at what if at least one of the terms has a squared term, which complicates things a little bit because we can't just use the same, well, we can't use exactly the same approach as with linear equations. So what the best thing we're going to do in this section, the best method approach which we'll look at in this section is substitution. And when you get to A level, it is a really important important skill to be able to get used to simultaneous. Well, yes, get used to simultaneous equations, but substitution. Okay, if GCSE you're really comfortable with elimination, I would try and steer a little bit away from that. It's still important to know, but we're going to look at solving these by substitution in this section. Okay, so let's just jump into it. Let's have a look at this example here. Solve these simultaneous equations. X plus 2y is 3, and x squared, which means it is now a what's it called? A quadratic simultaneous equation. So that's a quadratic term in. X squared plus 3xy. Now this is also a quadratic because it's multiplying two algebraic terms together. They're not the same because it's x and y, but they kind of multiply together to get a product of a product, right, of algebra. But it's the same way as saying x squared is just xx, right? So this is also a quadratic term, sort of. So we wouldn't be able to solve by such linear equations that way. Anyway, so we have 3xy equals 10. So how are we going to solve this then? Okay. Well, I did say we're going to use substitution. Okay. So what we're going to do is, if we call this equation 1 and 2, like we usually do, you don't have to, but it makes things clearer to label what you're doing. We're going to substitute, we're going to rearrange one of the equations to get one variable on its own. Uh, now, you should not rearrange the second equation because it has an x squared term. Whatever equation has the x squared part in it, it's best to avoid it because rearrange of x or y is going to get very nasty. So the first equation, because it's all linear terms, is the best thing to rearrange here. So what we're going to rearrange, we could pick either x or y. So we could say x is 3 minus 2y, or y is 3 minus x over 2. Now, actually, you could do either. I think this is the best. Um, what thing to substitute in because there's only one y term. We're only substituting one thing in the second equation. If we were to instead substitute x, you'd have to do x squared. So you have to do this squared. You have to expand and simplify some brackets, and you'd have to and then you have to put x here as well. So then you have to multiply everything by y. It's a lot more work to do. So it's best, although you don't have to, but it's best to substitute this in, even though it has an ugly fraction in, but that'll be okay. So what we're going to do, we're going to sub y into equation 2. So remember, if we rearrange, this is equation 1, right? So we need to put that into the other equation, into 2. We need to put that into the other equation to be able to solve it, because it's a different equation. Anyway, so if sub that in the second equation, we're going to x squared at 3x, and then y will be 3 minus x over 2 equals 10. Cool. And then we just expand this bracket, right? So we're going to get x squared plus. Actually, I'll tell you what the better thing we can do first is to get rid of the fraction. We could just multiply the whole equation by 2. Because then if we times it, times everything by 2, you get rid of this fraction. You get rid of the 2 at the end there. So we multiply everything by 2, we get 2x squared plus 3x, and then the bracket, and then well, what we're doing is we have 3x multiplied by 2, multiplied by 3 minus x over 2, but the 2 will cancel, right? So it'll simply left with 3 minus x, okay, which is the whole idea of why we times it by 2 to get rid of the nasty fraction, and that'd be equal to 20, right? Double 10. Make sure you times 2 to the left and the right hand side of the equation. Remember with GCSE, if you can change an equation by doing the same thing to both sides. Anyway, so this is a lot nicer to work with now because we've got no ugly fraction. So now next we can just expand this bracket, right? So we're going to get 2x squared plus 9x, right? 3x times 3 minus 3x squared equals, and I'm going to do minus 20 equals 0. Because what I notice here is that I have a quadratic, so I want to make it equal to 0 to solve it. Okay, but then I can simplify these terms, right? So I have an x squared and a 2x squared term. So 2x squared minus 3x squared is minus x squared plus 9x minus 20 equals 0. Cool. Then I could just whack it in the formula. I'm going to simplify it a little bit more by then divided by minus 1 to get rid of the negative on the x squared, to then get x squared minus 9x plus 20 equals 0, which is a bit nicer to work with. Can I factorise? I might be able to because I have to find two numbers at times to get 20 and add to get minus 9. But the factor of 20, I immediately spot that gives me minus 9 somehow is 5 and 4, right? Because minus 5, if I minus 5 minus 4 will get me minus 9, right? So they add to get minus 9, and then if I times them, minus 5 times minus 4, I get positive 20. So I can then factorise instead to say x minus 5, x minus 4 equals 0. And then has that equal to 0, then each factor has to be 0. Well, one of the factors will be 0. So we can say x equals 5 or x equals 4, right? If you set each bracket to 0, I get these two solutions. Okay. Okay, so we get two solutions then. These are the x values. Then remember, as it's simultaneous, there's also a y. I need to solve for y as well. Well, I have y here in terms of x, right? So I can just substitute x into this, right? This box here that's circled. How we got y. So if I just restate that, then y is over here, 3 minus x over 2, right? Yep, cool. Then I'm going to substitute just these values in then. So when x is 5, y would be 3 minus 5 over 2. That would go to 3 minus 5 is minus 2 over 2. That'd be minus 1. Then when x is 4, sorry, then I would get y is 3 minus 4 over 2. So that'd be minus a half, right? Let me move that there. Cool, I'll get minus a half. And those are our values, right? So in summary, we can say the solutions are x is 5, y is minus 1, and x is 4, y is minus a half, okay? So that's our solutions, and that's how we write it, right? So these are, so you get a pair of solutions, right? So x and y, um, uh, so each value of x and y, they have to come in pairs, right? Because for each x value you get, the y complement, so we have to substitute it in to get a value of y. So they are the same, right? So the idea is then, if you substitute that particular value of x, so when x is 5 and y is equal to minus 1, sorry, if you substitute those two values in to these equations here, right, the original simultaneous, that should satisfy it, right? So that should be correct. Likewise, if you substitute the other pair in, 4 and minus a half x and y, that should also satisfy the simultaneous equations. What you cannot do is mix and match. Okay, so I could not say x is 5 and y is minus a half to be a solution, because it matters what the pair is. Okay, because if you did that, 5 and minus a half x and y, that would not work. Okay, so you have to make sure uh, You have to really make sure that you do get the correct pair and write them down correctly. Okay. Okay, so that's a general gist. So that's what you'd expect with simple quadratic. Instead of one solution for x and y, you now get two. With the idea, well, usually two, because of the idea we get a quadratic, right? We explored in second chapter that the solutions of a quadratic, you could either get no solutions, one solution, or two solutions, depending on the discriminant, right? Which was b squared minus 4ac. And we will look at that actually in some later examples in a minute. Uh, but mostly you can expect right two solutions, right? Compared to linear, where there'd always just be one. Okay, or at most one. Anyway, let's have a look at another example then. So we can look at the exercise now. So we are given this question of one pair of solutions to the simultaneous equations, which is y is kx minus 5, 4x squared minus xy equals 6. So it's a quadratic because we have an x squared at the bottom. One pair of solutions is 1p. Now, this is a coordinate, okay? It's not written in the form I just written it in here, right? But I can, because a coordinate, we know, is just xy, right? So 1p means x is 1, y is p, okay? So that is one of the solutions. And remember then, if it's a solution, that means if we substitute it back, these values back into these two equations here, that would be correct, okay? So with that in mind, it's telling us for part A to find the values for K and P. Well, let's just work the information we got, right? So we got a solution given to us. Let's plug that in and see what we can get. So firstly, y, let's label these 1 and 2, right? Y is kx minus 5, but y is p. Okay, p is just a number, but we could just say it's p. That's equal to kx, but x is 1, so it's just k minus 5, right? That's equation 1. And then 4x squared minus xy 6. So x squared would be 1 as well. So we have 4 minus xy. Now x is 1, y is p. So it's just 1 times p, which is p. So 4 minus p is equal to 6. Okay, that's the second equation. Now notice I can solve these quite nicely, especially the second equation first, because I can solve for p. If 4 minus p equals 6, then p, it would be 4 minus p 6, so p would be 4 minus 6, right? If I move the p to the other side and then I move this, likewise the 6 back to the other side as well, I get this solution here. Okay, and then that's easily minus 2, right? There we are, cool. That's value of p, but now I can find that, sub that into the first equation to get k. So p is minus 2, so therefore, by the way, as a little heads up, this 3 dot symbol you might see means therefore, essentially. Okay, just a bit of notation. So that means therefore, if p is minus 2, then I put that into the first equation. Minus 2 is k minus 5. I can solve this for k as well. So k, if I add 5 to both sides, that'd be positive 3. And there we are. So find the value of K and P. Then it says for part B, find the second pair of solutions to the simultaneous equations. So now we know what K and P is, we can rewrite our simultaneous equations, right? As here as y is kx. Now k was 3, so that'd be 3x minus 5. And 4x squared minus xy is 6. Okay. So that's again to be equation 1 and 2. Now it's asked us to find the second pair. So to find the pair of solutions, we need to solve it, right? So we can solve it again. So we can substitute one equation to the other. Now they've been quite nice to us because they've already given us what y is on its own in equation 1. That's exactly what we can substitute exact equation 1 as it is into the second one, right? Because then I'm going to say sub y into 2, right? Because y is this from equation 1. Then 4x squared minus xy, that's x lots of 3x minus 5 equals 6. Then I can expand this, so 4x squared minus 3x squared plus 5x minus 6 equals to 0. I move the 6 to get an equation equal to 0. That I can solve. Then I can collect the terms. So 4x squared minus 3x squared is positive x squared plus 5x minus 6 equals 0. Um, okay. Then I'm going to factorize. I cannot be bothered to write down the formula. But can I factorize? Hopefully I can. So times the minus 6 and add to positive 5. What the factors are 6, right? 6 and 1. Well, I could get a factor here, right? Because 6 minus 1 gets us positive 5. So what, and I need negative 6 to, right, when they multiply them. So where should I put the negative, right? Well, one of them has to be negative, 6 or 1, because you times are getting negative. But I need a positive 5, so it makes sense to put the smaller numbers are negative. So 6 times minus 1 is minus 6. 6 minus 1 is positive 5, so there we are. That's our factors. So we can say x plus 6, x minus 1 equals 0. Therefore, if I put each bracket equal to 0, that's either x is minus 6 or x is 1. So those are two solutions. So which one then? Well, actually, they already told us in part A, remember, that one of them was x is 1. Well, that's great, because that means we're right, surely, right? Because x is 1 is one of the solutions to get. Well, then that means we need to look for the other solution, which is x is minus 6. So we're going to take x is minus 6, right? Because that's the other solution that we need to find, because it says to find the second pair what was it? The second pair of solutions. So they're giving us the first pair, remember, which is x is 1. Okay, well, x is minus 6. But remember, the y is this, right? 5x minus 3. 3x minus 5, sorry. That's equation 1. So then, therefore, if x is minus 6, y will be 3 lots of minus 6 minus 5. Which gets us 3 times minus 6 is minus 18, minus 5. Which should be minus 23. There we are. So to restate it, x is minus 6, y is minus 23. There we are. So that's our second pair. That's our second pair solutions. Cool. There we are. So I think what we're doing now is we're rearranging or substituting one variable. So rearranging one equation, right, to get a variable and put it into the other equation to get a quadratic we can solve, right? That's the main idea. Okay, cool. Let's have a look at number one. And actually, we can actually take this up a gear because of the fact I talked about this briefly earlier, right? That the fact that we get a quadratic equation at some point, that quadratic equation, depending on the discriminant, could get us various solutions, right? Depending on what it is. So remember, if it's greater than 0, it has two distinct solutions. Remember, we covered this in chapter 2 with quadratics. Or if b squared minus 4ac equals 0, we get one distinct solution. Or if it's strictly less than 0, negative, it has no real solutions. So that should be a reminder from from the work on discriminants we did earlier on in the quadratics chapter. So the idea is we can actually apply that to this, right? Because we get a quadratic uh, from solving the simultaneous equations, we can use a discriminant, right, to work some stuff out. So let's have a look at this example. So we are given the simultaneous equation versus 2x minus y is equal to 1, and x squared plus 4ky and 5k equals 0. So we can call these equations 1 and 2. Doesn't matter, but I like to do that. Okay, but we notice it's a bit awkward because we have this extra number k. Now k is just it's different to x and y. We're solving for x and y, but k is like a coefficient, right? It's just a hidden coefficient. Okay, it's a constant, right? We're not solving for k, but k is just a hidden constant, right? But it makes things harder because we can't actually get an actual number for x and y because this k is in the way. So then it says in part A, show that x squared and 8kx plus k equals 0. Might seem a bit out there, but really the strategy is with this type of questions is just do what you normally do, right? Don't forget k exists, but pretend it's just a number, right? Just solve it out how you normally would. So let's go about with substitution, right? I notice it's a quadratic for x squared. There's no y involved, but she's telling me I need to substitute y in. Okay. So I notice I can get y by rearranging the top equation, right? So if 2x minus y equals 1, then 2x equals 1 plus y, right? If I rearrange the top equation. Therefore, y is going to be 2x minus 1, right? If I move the 1 to both sides. And there we are. So we've got our what we're going to substitute into the y, right? What we're going to substitute into the other equation. So then I'm going to say I'm going to sub y into the second equation. Therefore, I'm going to do that over here. X squared add 4k y. Now 4k lots of 2x minus 1. Add 5k equals 0. Then I could expand the brackets to get x squared plus 8kx minus 4k plus 5k equals 0. Then I can simplify a bit more because I have two lots of k's here. So I have x squared plus 8kx plus k equals 0. And what do you know? I get the exact quadratic they wanted. There we are. So that's sort of the strategy, right? If you see a really out there part of the question, just solve it kind of how you normally would. Okay, and then eventually you should get to the right thing. There we are. Cool. So that's part A. Then it says we are given that this quadratic has equal roots. So that is pertaining to the discriminant. Remember, if it's describing about the roots, it's the discriminant. And when it has equal roots, that means there's only one distinct solution. Okay, because they're both the same, right? Um, so if they're both the same, then there's only one distinct because they're both the same, right? Because you can only have two solutions. Well, if they're both equal, then in actually you only get one distinct solution. Okay, they're not different. Okay, they're equal. So we get one distinct. Well, that's the same as this, right? That's when the discriminant is equal to 0. So that's what we're going to do. So let's consider the discriminant. So b squared is the coefficient of x, which is 8k. That's b squared, 8k squared, minus 4 lots of a. Now that's just a coefficient of 1, remember? Just a hidden coefficient of 1. 4k, and then c would be just k, the number at the end, and that's going to equal 0. It's equal to 0 because the discriminant is equal to 0 because we have equal roots, which means we have one distinct solution. Okay, distinct meaning different, by the way. So the roots are not different because they're equal, they're the same, so there's only one distinct solution. Anyway, so we get this equation because of the discriminant, then I can expand this bracket, right? 8k squared, remember, is 8 squared, which is 64k squared, so I have to square both numbers inside the bracket. Remember the index laws we did in the first chapter? So 64k squared minus 4k, right? If I times 4 by 1 by k, 4k. There we are, and that's equals 0. Now we can solve this, right? I can factor, I notice 4k goes into both terms, so I can factor 4k out to both parts, right? So 4k of 8k, right? Oh no, 16k. 16 times 4 is 64. So that would go to 64k squared. Then that's minus 1, right? If I factor 4k out of there, that's equal to 0. So I factorized it. So I can set each part equal to 0. So either the 4k equals 0 or 16k minus 1 equals 0. Remember how we looked at in the last chapter, we could look at factorizing expressions to get into factors to solve it that way. Okay, that means either k is 0, right? Or k would be 1 over 16. Okay, if I rearrange for k in that equation. Okay, so those are two solutions. Okay, but it said find the value of k. Now it says the value, which is singular, not plural. So it's saying there's only one solution, but we've got two here. So how do we determine which one we take? But let's have a look at the question. It says, but k is a non-zero constant. Non-zero mean, well, it cannot be 0. Well, that means we cannot have this. So k is non-zero. Let's write that properly. K is non-zero. So therefore, we can only take case 1 over 16. So that's our solution. Cool. So we found the value of k. There we are. Then it says for part C, for this value of k, find the solution to the simultaneous equations. Uh, so the solution, well, remember we already did part of it already. For part A, we substituted y to get this quadratic. So we need to solve this quadratic, right? So we just plug in the value of k we just found. So I'm going to restate the quadratic. X squared plus 8kx plus k equals 0, right? That was the quadratic we got in part A. Yes. So we could just substitute this value of k in. So therefore, x squared plus 8 over 16th x plus 1 over 16th equals 0. If I then deal with this bracket, expand it, I have x squared plus 8 over 16, which would be half. X plus 1 over 16 equals 0. Okay. I don't like fractions, so I'm going to times both sides by 16 to get rid of this fraction here. And because 16 over 2 will get me 8 here, so that'll get rid of that fraction too. Anyway, so I'll get 16x squared plus 16 over 2, which should be 8x, plus 1 equals 0. So that's a lot nicer, but I don't like this coefficient, so I'm not going to solve by factorising. I'm going to just use the formula, right? So then x is minus 8 plus or minus the square root of b squared, which should be 8 squared, minus 4 lots of 16, lots of 1, all over 2 lots of 16, right? Which will get me the solution. Now, and actually, how many solutions are we expecting in this case? It should only be one, right? Because remember, we discussed there's only one distinct solution to the quadratic. That's what we were told in the question. So I should only get one solution out of this. So x is minus a quarter. Actually, yes, that's the only solution. If you press equals, yeah, that's the only solution the calculator gives you. So there we are. So actually, we know we've done it. We're probably right so far because we only got one solution, like we expect. So that's our value of x. But it wants a solution to the simultaneous equation. So we found x, that's great. But then we need to find y. What's the corresponding y value? Because remember, we need a pair of solutions. Well, we know x is minus a quarter, so then to get y, I know this, don't I? That's what I substituted in at the very start. Y is 2x minus 1. So y is 2x minus 1. So when x is minus a quarter, that's going to be 2 lots of minus a quarter minus 1. Which then would be, put that in a calculator, if you're lazy like me, we had to work that out, you get minus 3 over 2. Cool. So therefore, that's our solution. So when x is minus a quarter, y is minus 3 over 2. And that's our only pair of solutions. Now notice here, in this question, again, we only had one pair of solutions in this case, not two, like the other two examples, because of the fact of the discriminant, right? The discriminant in this case was equal to 0. So if you look here again, what we discussed up here, it only gets one distinct solution, so we only have one pair of solutions. In the other two examples, the quadratic we got, which was here, right? The quadratic here, the discriminant would be greater than 0, so that gives two distinct solutions. Same way here, when we got this quadratic here to solve for x, that discriminant, if we work it out, would be greater than 0, so that would also give two distinct solutions, therefore two distinct pairs of solutions. Okay, there we are. So that's really it, right? We can combine, you will get used to that throughout the spec. They do like asking questions and putting multiple topics together. So in this case, we link discriminant right to this topic. They do like asking that to make sure you are comfortable with what we've done there. Okay, final question. I'm going to leave off, which also deals with discriminant, right? Again, um, try not to get the circle in the box. Okay, so it's a challenge question, but it's not that bad, right? From the textbook, but it's not that bad. Perfect, it could be asked in the exam, really. But let's have a look. So we're told the simultaneous equations y minus x is equal to k, and x squared plus y squared equals 4, which is equation 1 and equation 2, as we call it. It says, given that the simultaneous equations have exactly one pair of solutions, so again, think about when that happens, like the last example, it might discriminant, what would that mean? It needs to show that k is plus or minus 2 root 2. Okay, so I guess the difficulty with this one is mainly it seems a bit out there, right? Just giving you this equation, show this, right? Okay, it's a bit unstructured, just show it. But again, like with the last example, just solve it how you normally would, then try and think about what you got. Okay, so how do we solve it? Okay, well, first we want to substitute. So I could either rearrange it x or y. Um, okay, I've done y this whole time. I'm going to rearrange for x now. Okay, so y minus x is k. Then I'm going to rearrange for x, and then I'm going to plug that in for x squared here at equation 2. So that would mean x then, or y minus k would be equal to x, right? If I move x to the other side and then k to the other side, I get y minus k equals x, or x is equal to y minus k. By that, I'm going to put that into the second equation. So I'm going to sub x into equation 2 to then get, well, x squared would be 1 minus k squared plus y squared is equal to 4. So now I get a quadratic for y, and it has k, but k, remember, is just a number, right? It's not x or y, so we don't really mind. So it's just y really. So let's expand this. So y minus k squared, remember, it's 1 minus k, 1 minus k. You times by itself plus y squared is equal to 4. I can expand this bracket to get y squared minus ky minus another ky, you get 2ky minus 2ky minus k times minus k positive k squared, because the negatives get a positive, right, if you times them. Then plus y squared is equal to 4. Then I'm going to rearrange, collect the terms to simplify this. So I have y squared here and a y squared here. That'd be 2y squared. Then I minus 2ky, so a y term of minus 2k. Then I have just this plus k squared. Then I'm going to move the 4 again to the other side to make it equal to 0 to solve. And that's really it, right? We can't simplify it anymore. And you should remember this resembles now a quadratic, right? So if I said a was 2, the b coefficient would be minus 2k, and the c would be this number at the end. This is a quadratic, right? It has k in. Yes, it's not a nice one, but remember, k is just a placeholder number, right? It's just a hidden number, if you will. So don't worry about that. K is just another number, but there we are. Okay, now it's told us. So again, if we really we can't really solve it at this point. Well, it'd be quite nasty to solve, right? Because there's this k bit here. But let's have a look at the information. It's told us that the simultaneous equations have exactly one pair of solutions. Okay, well, what does that mean then? Well, if it only has one pair of solutions, remember, it has like x, y, or x is equal to blah, 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 or y is equal to something else. That there's only one solution here. Well, that means there's only one y and one x value. But that means then, if we solve this quadratic, like in the last example, that would only have to give one solution for y. Okay, that has to happen. So they cannot get two solutions. It has to be exactly one solution if we were to solve the quadratic. Well, that's the discriminant, isn't it, again? Because if it's only one solution, one distinct solution, but the discriminant has to equal to 0, right? In order to get one distinct solution, okay? Which will then give us one pair of solutions at the end. So we only get one y value out of this. But then the discriminant, we know what that is, right? We can work that out quite easily because we know what the a, b, and c terms are for the coefficients of the quadratic. So let's set this then. So b squared is minus 2k all squared. Cool. Then I get minus 4, lots of a, which would be 2, of c, which would be k squared minus 4. that has to equal 0. Okay, cool. Now we could expand this. So that'd be minus 2k all squared, that'd be 4k squared. Minus 4 times 2, which should be minus 8 of k squared minus 4 equals 0. We can expand this bracket then to get 4k squared minus 8k squared minus 8 times minus 4 will be plus 32 equals 0. Then I can collect the k squared terms to get minus 4k squared plus 32 equals 0. Then I can move the 4k squared to the other side to get 4k squared is equal to 32, right? Then I can divide by 4 to get just k squared is 32 over 4. Now that would be 8, okay? Okay, well then that's k squared. Then I could just take roots of both sides. So k would be plus or minus root 8. Now plus or minus again is equal to solving, okay? So we want the plus or the minus. We want every possibility for k. So plus or minus the square root of 8, because minus 8 squared all would be positive, right? Same with plus 8 squared. You know what I mean? Anyway, because so with plus or minus, that should be fairly clear, hopefully. So yeah, plus or minus root 8. So that's a solution for k then, right? Okay, but then it says that k is plus or minus 2 root 2, but I have plus or minus root 8. Okay, so what that's telling me is I need to simplify this. This is a third, isn't it? So this is now linking back to thirds that we did in the first chapter, remember? And we can simplify thirds by considering what's under the square root, right? So we have 8. What goes into 8? What square numbers go into 8? Well, root 8, remember, is we can say it's 4 times 2, right? And 4 is a square number. That means we can simplify it, okay? Because root 4 will be a nice, it will go to 2. So remember, we can split this up to root 4, root 2. Remember the third law, root AB for any numbers A and B. We can split that up to equal root A times root B. Okay, that's the third law you should remember that we did in the first chapter. So that'd be root 4, root 2. Well, root 4 is 2. And then root 2 is just root 2. We can't simplify that any further. But then if root 8 is 2 root 2, then k is plus or minus 2 root 2. But isn't that exactly what they wanted? And there we are. Yes. There we are. Cool. There we are. So that's really it. So hopefully you see what we're doing there, right? The whole idea is essentially we substitute one equation to solve quadratic simultaneous equations. We rearrange one equation and then substitute that into the other to get rid of one of the variables. So we substitute y or x or whatever. So then we should only get a quadratic for x or y, which we can then solve. Okay, and in harder examples, that quadratic we can consider the discriminant to work out any other missing values like k, for instance, like here, right? K as a coefficient, we can consider the discriminant to work out any missing values, okay, to help us with solving the equation. Okay, and this one's quite nice. It combined pretty much a lot of stuff we learnt so far. So the discriminant, but also thirds, weirdly enough. I like that example. But yeah, hopefully you followed what happened there. And I would say you try to start getting used to these sort of questions. It is a step up from GCSE. You know, there's more things, more algebra you have to do, but hopefully you can start to understand the ideas behind it, right? And you should, if you're starting in the course, hopefully you will get more used to it as the time goes on. But yeah, I will leave that there then for now.